Hey everybody, so we are looking at this problem, palindrome number. It is a very easy but a very interesting problem because the concepts you learn here can be used in many other problems. So we are given an integer x. We need to return true if the number is a palindrome. Let's say 1 to 1. From the left and from the right, it reads the same 1 to 1. So this would be a palindrome. Over here, from the left, we would also consider the negative. So negative 1 to 1, and from the right it's 1 to 1 negative. This is not the same, so this would be false, which also means that every negative number would not be a palindrome. Any negative number would never be a palindrome for us. Over here 1 0 does not read the same as 0 1, so we would also reject this. This is no longer this is not a palindrome. If this was a string problem, if 1 to 1 was a string, it would be very easy. Keep a pointer here, keep a pointer here, just traverse this string from the left and from the right and keep comparing, compare this until you reach the middle and you're done. Since this is a number, we don't have a direct way of pointing to the right side of it. And also, we can't read it from the left because we can only read 1 to 1. How do you read 1? How do you read 1 over here? And for that, we need to understand certain concepts. The first one is the modulus operation. If we take this number 1 to 1 and we modulus with 10, what do we get? We get 1. We managed to read this one. If it was 12 mod 10, that would be 2, which means we managed to read from the right. But once we have read 1, we need to do something to make this 1 to 1 to 12. And to do that, we would need another concept, which is integer division by 10. So let's take 1 to 1. Integer division by 10 would be 12. So basically, if we use modulus and integer division, we can reduce the size of this number. We can keep reading its last value, its least significant bit, one at a time, and we can recreate this number from the right. So over here, that would be in the recreation, it would be 1. Then we extract 2 out of it. And then at the end, we extract 1 out of it. Then the number becomes 0 and we no longer worry about it. So that would be 1 to 1. Let's take another example. Let's take 1 2 3. Let's do modulus of 10. We have 3 in the output. Let's do integer division by 10. We get 1 2. Let's do modulus by 10. We get 2 in the output. Let's do integer division by 10 and we get 1. Let's do modulus by 10. We get 1 over here. And then we do integer division by 10. We get 0. When we reach 0, we no longer go forward. We have the number 3 2 1, which is not the same as 1 2 3. So we reject this as not a palindrome. We return false. Now this would be the basic concepts required to solve this problem. Let's take a look at the code implementation. I am here in the code editor. We have this function is palindrome. It has a parameter called x, which would be the number given to us, and it returns a bool. First of all, since I am going to manipulate the number, I don't want to modify the actual number. So I would just store it in a different value so we can preserve it. So n is equals to x. I would modify this number. And we want to modify this number as long as it does not become 0. So n greater than 0. The first thing is going to be value. which would be the least significant bit or the least significant value that I have. So n modulus 10 would give me that least significant value. I can also have a variable that I can call reverse, and this reverse would be the reversed value of x. So over here, I can say reverse is going to be equals to reverse multiply 10 plus this value. So how does this work? If I have a number like 1, 2, 3, and I want to make it 3, 2, 1, I extract this value and I want to move this forward like this, which means initially it was at least significant bit and it became the most significant bit. If I have something like this, reverse is equals to 0 right now. So reverse would become 0 plus the value 3. The next time I want this to have its component as 300. To make it 300, I would need to multiply 10 every time I take one of these values, which means when I take the value 2, the reverse is 3 over here. The reverse would become reverse multiply 10, that is 30 plus 2. In the next iteration, when I have 1 over here, reverse would become this is 32. 32 multiplied 10, 320 plus this last element 1, and that would be 321. And that is the reason we would multiply in reverse 10 over here, and that would recreate this kind of number. Once we are done with storing this value in the reverse, we need to modify n. So I can do n equals to n mod 10. This would, you know, destroy the last element. We have a smaller number left. Once I'm done with this, I can make a very simple comparison. If reverse equals to the original number, let's return true. Otherwise, let's return false. Now, what happens if we have a negative number? So that we can handle at the top. If x is less than 0, we can just return false. Let's try to run this code. Let's submit it. We have it passing.